Hello good day viewers. In this tutorial we are going to find the derivative of tangent x from the first principle. So let's get started. As always, we are going to start with the formula. The derivative dy over dx is equal to the limit as h approaches 0 of the function f of x plus h minus f of x divided by h. You should know that f of x here is nothing but tangent x. All right, let's substitute. So this is equal to the limit as h approaches 0 of f of x plus h, meaning tangent of x plus h, right? Tangent of x plus h. The minus f of x, which is the original function, that is tangent of x, divided by h. You should know that tangent is nothing but a ratio of sine and cosine. So tangent x is the same thing as sine x divided by cosine x. So we can rewrite tangent of x plus h as sine of x plus h divided by cosine of x plus h. So we have the limit as h approaches 0 of sine of x plus h divided by cosine of x plus h. The minus tangent of x is the same thing as sine of x divided by cosine of x, right? Don't forget to divide by h. Now I would like to simplify these fractions. So this is equal to the limit as h approaches 0 of, to simplify this, we can take this and multiply by this, right? So it will be sine of x plus h multiplied by cosine of x, then minus, we take this, we multiply by this. So it will be cosine of x plus h multiplied by sine of x, divide by the product of these two. We're going to multiply them together. So it will be cosine of x plus h, then multiply by cosine of x. Don't forget the whole of this will be divided by h, right? Which is the same thing as multiplying this denominator by h. It's all the same thing. So let's move to the next step. One thing you should remember about this identity is that if you have sine of a minus b, this is the same thing as sine of a multiplied by cosine of b, the minus cosine of a multiplied by sine of b. So if you look at this, is somehow related to this, where our a here is x plus h and b here is x. Therefore, we can write the whole of this as sine of x plus h minus x. So let's do that. So we have the limit as h approaches 0 of sine of x plus h, right? Then minus x. That is our numerator here. Then divide by the whole of this times this. So it will be h multiplied by cosine of x plus h, then multiply by cosine of x. So if you look at this, this and this will cancel, leaving only h, right? So this is equal to the limit as h approaches 0 of sine of h alone, divide by h multiplied by cosine of x plus h multiplied by cosine of x. So from here we can split it into the limit as h approaches 0, this divided by h, right? So we have sine of h divided by h, then multiplied by 1 divided by cosine of x plus h multiplied by cosine of x. If you multiply this by this, you're still going to get this back. So remember that limit of a product is the same thing as product of the limit. So we can split the limit into the limit as h approaches 0 of the first one, which is sine of h divided by h, then multiply by the limit again as h approaches 0 of this, which is 1 divided by cosine of x plus h multiplied by cosine of x. So we're going to treat the two limits separately. Remember this from squeeze theorem, it is equal to 1. And this one, all we have to do is to substitute h equal to 0, right? So plug in h equal to 0 here, we have x plus 0, which is just x. So this will be 1 multiplied by 1 divided by cos of x times cos of x. 1 from this and this from this, right? So you see that cosine x times cosine x will be cosine squared x. This is equal to 1 divided by cosine squared x. So what is 1 divided by cosine squared x? It's nothing but secant squared x, right? So this is equal to secant squared x. Therefore, we conclude that the derivative of tangent x is nothing but secant squared x. Thank you for watching. Do share to your learning colleagues and don't forget to subscribe to my YouTube channel for more exciting videos. Bye-bye.